In this video we are going to prove the chain rule for the derivative of the composition of two functions. We are going to use differentials. You may want to check my video on differentials for a proper definition of differential. Let's recall that differential of a function f of x is defined as f of x plus differential of x minus f of x, being differential of x an infinitely small increment of x. For our second function, g of x, we have exactly the same. Differential of g of x is defined as g of x plus differential of x minus g of x. Now I'm going to remind you what the composition of the two functions means. The function f composed with g is a function of x in which we apply first g to x and then f to the result. Let's square this formula and save it in this corner for later. Now let's find differential of f composed with g of x. Applying the definition, it would be f composed with g of x plus dx minus f composed with g of x. Or, applying the formula we saved here to this, we get, and here we apply the formula and we get, well, now let's make a change in this equality. So we are gonna bring this to the other side. Now this is the same as this, so we can replace this here by this. Let's divide and multiply by the same amount. That is differential of g of x. Divide and multiply by differential of g of x. So nothing changes. And now let's divide on both sides of the equation by the same amount as well. Differential of x, differential of x. And we get what we wanted to prove, the chain rule, because this is the derivative of the composition of both functions. This is the derivative of f as a function of g, and the remaining part is the derivative of g. So we come up with the chain rule.